Match Fishtank, Unit 8, Lesson 8. Before you watch this video, make sure you've attempted the anchor problems for this lesson, because in this lesson, you really want to play around with some of the data and see what's happening to the mean and the median as you change the data points. Our goal here is to figure out which measure of center, the mean or the median, best represents a given data set and why. So in anchor problem 1, we have Bobby, who competes in the hurdles. That's a running race, if you've not seen one, where you have to jump over basically a little obstacle multiple times in the course of the race. So she's had 8 track meets, and she's recorded these times, which look pretty good, except there's a couple that are different here. I'm going to say those are probably outliers, and those might affect my data. So my first task is, what is the mean of Bobby's times for the track meets, and what does it tell you in terms of the context? Here is how I calculated the mean. I added up all the numbers in the data set, and I divided by the number in the data set, which is 8. And I got that it's 21 and 74 hundredths seconds. But the next part is the really important one. The mean, what does it tell me in terms of the context? That tells me how long it should take, I might predict that Bobby would take on her next 100-meter hurdles if I'm taking into account all of this data. But some of this seems to be cast in doubt because many of these are right around 18 seconds, and then a couple of them are higher. So I don't know that that's really a very good predictor of her next race. By being a predictor of her next race, I mean a measure of center for the data set. So now we're going to take a look at the median of Bobby's times. In this case, I've lined up all of the numbers in order from smallest to largest. I've identified that there are 2 middle numbers, so I found the halfway point between them, and I found that the median was 18 and 500 seconds. Now, in this case, this tells me that that was the middle time of all of Bobby's times. So here, the higher numbers don't have quite as much of an effect because I'm more looking at these numbers here, as long as I have a bunch of numbers that are in the range of about 18 seconds. My higher ones don't make as much of a difference. And that's exactly the explanation here. The mean is higher than the median because 2 of those numbers are so much higher, these ones here, that they pull the mean to the higher end. Since I add up all the numbers and divide by 8, if all of my numbers were close to 18, then my answer would be pretty close to 18 also. But these 35 and 31 pull it higher. That's a lot easier to see if we take a look at the dot plot. So our next question is, which measure of center do you think best represents Bobby's 100-meter hurdle time? And I think the median is the best representative because the median would fall right about here. Remember, we said it was 18 and 5 hundredths, whereas the mean would be right in here. And I can see that these 2 times really there are real outliers out here. It's definitely a skewed data set. So now we're given a reason for those times that were more than 30 seconds because Bobby fell. So I'm going to calculate the new mean, and the new mean is right in line with where we would expect it to be if we take those out, just under 18 seconds. And calculating the new median, it's also just under 18 seconds. So in this case, they're much closer because the mean's not being pulled in this direction of those outliers. And if Bobby had 10 more track meets and didn't fall, then I would think that her times for the track meets would be right around or just under 18 seconds. So if I put all those in with my original data set, this one in the dot plot, I'd have a bunch more dots right here around 18. That means my median is going to stay down here and my mean will be pulled a little bit more, but since I'm dividing by 10 more, it's going to be closer into this 18 mark. All right, so now we're going to apply these same ideas to another data set. This one having to do with Michael Jordan. So in this case, the mean is pretty misleading because Michael Jordan's salary is definitely an outlier. And if I were to draw a dot plot here, I might imagine that here are some representations of the other people. I don't know how many people graduate in geography, but we're just putting a few in here. And somebody makes a little more, and somebody makes a little more. And then here's Michael Jordan. Let's change the color. Here's Michael Jordan way over here. So just like the case we had in the last problem, when we have Michael Jordan way out here, that's going to pull the mean way out towards the side of his salary. And so I think that the median would be a much better measure because the median's going to be in here where the biggest cluster is. Now, if we were to take Michael Jordan's salary and imagine that it was still the highest salary, but it wasn't as high, like I'm showing with this green dot here, then the median's not really going to change here from the green dot to the red dot. It can't because I'm just looking at the middle number. And remember how we counted in from the dots on either side? Well, this is still the highest dot. So the median wouldn't really change there. But the mean is going to change because I'm adding in so much of a higher number of an NBA high salaried starter compared to an ordinary but hardworking geography major. So that can help us understand that when there's an outlier or a really skewed data set, the mean will be pulled in the direction of that outlier. And in that case, the median is probably more representative of the center. An interesting thing to think about would be when try to figure out a data set when neither the mean nor the median would give you an accurate picture of center. So we're going to scroll down again and think about just what happens to a data set when we change it around. So here we have the morning commute time of 8 different people, and this 5 was an error. And instead, it should have been 50. So we want to figure out what happened to the mean and the median without calculating them out. And one way we can do this is by visualizing in our head, we don't even need to write it out, our dot plot. Because our 5 would be way down on the right-hand side. And our 50 would be way up, but not as way up, on the right-hand side here. So the 5 is much further down because the next one there is 20, but the next lower one from 50 is 45, so it's not nearly as low there. That tells me that the Mean is going to be pulled down. It's going to be smaller than the mean with the correct data, because in order to find the mean, you have to add up all the numbers and then divide by how many there are. Well, with the typo, there's still the same 8 numbers, but your sum that you add up all the numbers to is going to be lower. So then if you're dividing by the same thing, you're going to end up with a lower mean. The median's going to be just a little bit bigger, because on one hand, when I have the typo, I have an extra data point down on the left-hand side. But when I put in the correct number, I have an extra data point up on the right-hand side. So if I'm counting in on my two sides, my smallest one in the correct data set is going to be 20. And my largest one will be 50. So that's going to pull the median one number over to the right. This type of analysis takes practice. Uh, Try experimenting with different types of data sets and seeing what happens, and seeing if you can start to predict what will happen to the measures of center and what will most accurately represent the data set. This can set you on the path to being able to use this type of analysis to question statistics when you're given them in everyday life, and make sure that what somebody tells you is a typical value really is a good measure of center for the data set.